In this video, we'll be combining the translations and dilations we introduced previously. Now, things sometimes do get a bit confusing at this point when we start mixing things together. A nice thing though is generally, horizontal and vertical transformations don't really get in each other's way. So what we'll do in this video is treat them separately, and I might leave it to you to put them together as necessary as you do your work. So we'll start with the vertical ones, again working with the sine wave. So let's look at y equals 2 sine x plus 1. Now multiplying the sine x by 2 carries a vertical dilation by 2, which means things are vertically stretching by 2. Okay? The plus 1 translates things up by 1. Okay? The important thing here is which order these transformations are applied, because it makes a difference. Okay? If we do the dilation first, then the translation, it stretches first, meaning 0 stays at 0, plus 1's double to plus 2's, minus 1's double to minus 2's, and so on. Then it pushes it all up by 1. So now the sine wave doesn't bounce around y equals 0 anymore, but around y equals 1. The amplitude is still 2, so it must be bouncing back and forth between -1 and 3. Okay, I'll leave a shadow of this in red and see what happens if we go the other way. So let's say we do the translation first, then the dilation. It goes up by 1 first, meaning it now bounces between 0 and 2, okay, because the amplitude has not changed yet. Then the y values double, but like we were saying in the previous video, when we do this, all the zeros stay where they are, because double 0 is still 0. But the maximum values of 2 get pulled all the way up to 4, so it ends up here, which is noticeably different from the red one that we had. Okay, so who's right? Well, the easiest way is to remember that the sine x component of the equation hasn't actually changed, right? So x and y, and so the axes themselves, didn't transform. Things just happened to the y value. So what happened to this y value? What happened to sine x in the lower equation? Well, the multiplication needs to happen first, so the y values get doubled, stretching the graph, and then the plus 1 happens afterwards, pushing it up by 1. Okay, so the order here would be as we wrote it, the dilation first, then the translation. And that's the graph. Let's try the same thing with a couple of horizontal transformations. So this time we'll look at y equals sine 2x plus pi. Okay, the 2 is a horizontal dilation by a half, so it squishes things horizontally to half the size. The plus pi would be a translation left by pi. Okay, now things are happening again in reverse because it's transforming the axis by changing what x itself is. So once again, the order is the key thing to understand here. If we do the dilation first, then the translation, well, the graph has to squish first and then move. And once again, I'll leave a red shadow there, but if we translate first, then dilate, it moves across first and then squishes. And once again, we see the results are different. So who's correct this time? Well, we need to once again track how we got from the basic sine equation to the transformed one. So notice that in this equation, it's still just y equals sine something. So actually the form of the equation hasn't changed, only the x-axis, right? Because x itself has been transformed. Which means at each step, the x is changing into something different. Now really note this fact. It's not about any multiplications or additions. It's actually x changing and becoming something different. Okay, so let's start from the plain old sine x and see how to keep on changing the x until it becomes sine 2x plus pi. Okay, so let's say we try the dilation first again. So x becomes 2x. Then we do the translation. So x becomes x plus pi, but you see how if x is changing into something else, the entire x changes, and so we need to bracket that expression. And that's where we see something has actually gone wrong here. This expression isn't the one that we were looking at. Okay, let's try the other way, translation first. Okay, so from the beginning, we change x into x plus pi. Then we do the dilation. Okay, we change the x into 2x. Now you can see, like algebraically see, that's the correct one that we're after. So in fact, the correct way is to do these two in the opposite order. We translate first, then dilate. Now, at this point, we often hear protests like, oh, order of operations has been broken, the plus happened before the times, but really, I want you to see this has nothing to do with operations because there are no operations happening. We're not calculating what 2 times x plus pi equals. There are no calculations here, right? X itself is changing one step at a time until it becomes 2x plus pi. And the only way to get there is we change the x to x plus pi, then change that x into 2x. Okay, now all of this is so far an awfully algebraic argument for why the order is translation first in this case, and it's valid, okay, but I think it's satisfying to also have some meaningful graphical interpretation. Okay, so let's return to that lower equation again for a moment and think about what happens if x is 0. Okay, so the whole 2x thing vanishes for now, which means we need to start our graph at an angle of pi. Right, now where is pi on a regular sine wave? That's half a cycle in. It's halfway around the unit circle. Then the 2 kicks into gear, causing us to run along the wave twice as fast, which is squishing the graph in, which is exactly the order that we looked at just then. Okay? But, okay, let's pause a bit here. Again, rewind if you feel you need to understand some of that more clearly. Okay, because what we're going to do next is where things typically get a little bit tricky. Okay, because now what I'm going to show you is visually what's wrong with doing this the wrong way around. And we've seen algebraically what's wrong in that when you transform the x the wrong way, well, the equation just ends up being something different. But visually, what's happening when we do it the wrong way around? Okay, to explain this one, we're going to move the axis again, right? So I'm going to recolor the axis blue and make that one transform so we can keep a reference to the original axis in white. Okay, so hopefully that's not too confusing. So this is the incorrect order. If we do the dilation first, the x-axis stretches out like this. Then we move the axis across by pi to do the translation, but notice how in the original coordinate system, that's now 2 pi. Right, the problem is that by dilating the axis first, right, we're stretching the effective size of the translation. We're letting the dilation, right, affect the translation as well, right? And actually, this 2 pi thing is perfectly consistent with how in the top right corner here, the inside actually expands to 2x plus 2 pi. We see also algebraically, the translation has now been doubled as well, and that's the problem. Okay, we've allowed the dilation to reach the translation and to affect the size of the translation as well. And that's also why if you look at where our axis has ended up, it's shifted one entire cycle of the wave across, and the graph sort of starts one complete cycle ahead. Whereas again, if you look back at the equation we're going for, again by putting x equals 0, you should see the graph is only meant to start pi ahead, which is only halfway around the circle. So once more, the correct way in this case is to do the translation first, then the dilation. Don't memorize this as a horizontal vertical thing because that's going to confuse you, and if you get it mixed up in whenever you need to use it, it's not going to be helpful. Rather, you need to be very careful again with whether it's the y or x value being directly controlled or whether x and y themselves are changing. I keep saying this, but it's that important, okay? And use those ideas to determine the order in which those transformations should happen. Okay, this isn't easy stuff, so it's okay if it's a bit confusing right now, okay? Rewatch if you need to, but as always, feel free to ask if you have questions or comments, and I'll see you around.